Alright guys, today we're going to finish up chapter 11, which was on acids and bases. We're going to finish it up today with a topic that is called titrations. So, just barely in class, I showed you what a titration was and why a chemist would perform a titration. So a titration is a lab technique. You set up like this, so you have a ring stand here, and on the ring stand you have a clamp, and it's connected to this burette, which is a long glass tube. On the burette you have these markings, so you can actually measure how much volume of a solution you put in there. On the bottom of a burette is called a valve here that you can open or close. If you open it a little bit, you can just let it go in dropwise. If you open it completely, it flows out pretty fast. So this is what a titration looks like, and they put a flask underneath. So that's the topic of today's lesson, is a titration. So I first want to go through the notes. So if you're watching the video, you're going to need your chapter 11 guided notes out. There's a little bit of notes to fill out. Also, you're going to need a calculator. All right, let's get started. So here's why a chemist would perform a titration. It goes back to this right here. It says, what if you needed to know, what if you needed to use an acid in your chemical reaction, but the bottle of acid doesn't mention its concentration? So you need to use some acid, but the bottle, I don't know if it's been scuffed or maybe the wrapping has been removed and the label's gone. You don't know its concentration. So how could you determine the concentration of that acid? Is there a way to figure it out? And the answer is yes. How? You could figure it out by performing a titration. So that's what we're going to explain in the next slide. So in a titration, you will need what is known as a standard solution. The standard solution is a solution of known concentration. So you would have a solution that you do know the concentration of. In your guided notes, you're supposed to write down the definition of a titration. Here it is. A titration is the process of adding a specific amount of a known solution to an unknown solution to determine the molarity of the unknown solution. Now that's a long definition, I know. So write it down. Let me go through it one more time. A titration is the process of adding a specific amount of a known solution to an unknown solution to determine the molarity of the unknown solution. When you do a titration, you're doing an acid-base reaction. When you mix an acid with a base, what kind of chemical reaction is that called? We talked about it last lesson. What are they called? When you mix an acid with a base, what are you doing? You're neutralizing it. So this is called a neutralization reaction. So you're heading to a neutral pH. When you are done with the titration, you will know you're done when you reach the equivalence point. Equivalence means equal. So in your margins where it says equivalence point on your notes, I want you to draw an equal sign. The equivalence point is where something equals something else. And like it says here, the equivalence point is the point at which the moles of acid, the moles of H plus from the acid equals the moles of hydroxide. So the equivalence point is reached when moles of acid equals moles of base. When that occurs, what is your pH? When moles of acid equals moles of base, what's your pH? Your pH is 7. Remember, that's neutral. So when you reach the equivalence point of a titration, you're at pH of 7. Well, if you just look at a solution of acid or a solution of base, a basic solution or an acidic solution, can you just look at it and tell the pH? You can. They both look like colorless solutions, right? They're both clear. They look like water. So how do you know when you've reached the equivalence point? You have to use a what? You have to use an indicator. Okay? You can't tell a pH of a solution just by looking at it. You've got to use an indicator. So what is an indicator? Here's the definition. And you're supposed to write it down. Indicators are chemical dyes whose color changes when reacted with an acid or base. So they change colors. These indicators will change colors based on what pH it's at. Some examples of indicators. I just showed you a demonstration with phenolphthalein. That was the magic picture demonstration where it changed colors from pink to white, pink to clear. Phenolphthalein is one. Well, there's also other indicators. Bromothymol blue, universal indicator. We showed you a universal indicator in class last time. And this chart right here just shows you all the different indicators. There's two that I want you to know for sure. Okay? Phenolphthalein, the magic picture demonstration that I just showed you. And also, universal indicator. Now, my favorite one is universal. How come? Yeah, it's got all the colors of the rainbows. If you look at the universal indicator, all the color of the rainbow here, based on what pH. So if you're at an acidic pH, a strong acid, what color is universal? What color is it? It's red. Well, what if you were orange? What's the pH? Well, right around 5. If it's yellow, the pH would be 6. It's green at a pH of 7. So we would know exactly what the pH was based on what color was present. Indicator, very important that you understand what they do. They change colors based on the pH that you're at. So it lets chemists know by looking at it what the pH will be. For example, universal indicator is one of the most well-known and used indicators. All of the different pH values here are represented with a different color. Guys, how do you remember the colors of the colors that are present in a rainbow? Roy G. Biv, right? Roy G. Biv. What does the R mean? Red, orange, yellow, green, blue, indigo, violet. You see all of those colors with universal indicator. And what's cool is that each color is a different pH. Okay, so let's move on. Here's a graph of a titration. So if we had a strong acid in this flask right here, but we didn't know its molarity. But let's say we did know that there was, 50 milliliters of the acid. How could we determine the concentration of that acid? Well, we would perform a titration. So what you do in a titration is you fill this burette with a strong base or a base solution. Maybe it's 2 molar concentration of sodium hydroxide. And we can measure how much base it takes to completely neutralize the acid. Now, how do we know when we're done? How do we know when we've reached the pH of 7? You've got to use a what? Indicator. So you put an indicator in here and it will change color. You pick an indicator that changes color near the pH of 7 and then you'll have it. Okay, and that's what they do. So in titrations, the pH will change very quickly around the equivalence point. So notice here, you can put in a bunch of the base and the pH doesn't really change, but when you're at the equivalence point, the pH is going to change really dramatically. And you notice when I did it, at the end, you're just putting in very, very small amounts because it's changing very quickly at that point. Okay, so what if it took 30 milliliters of base to completely neutralize this acid? How could we determine what the concentration of that acid would be? Well, we would use the neutralization formula. Okay, we would determine the molarity of the acid. We don't know it, but we could determine it. What was the volume of the acid? 50. What was the molarity of the base? The molarity was 2 molar. And what was the volume of base that it took to neutralize it? Was 30. Okay, so you divide both sides by 50 here, and you would have the molarity of the acid by doing that calculation right there. So in titrations, we're using the neutralization formula to figure out the molarity of an unknown solution. I've got a couple of practice problems to finish with. Practice problem 21. It says it takes 83 milliliters of a 0.45 molar solution of sodium hydroxide to neutralize 235 milliliters of HCl solution. HCl is hydrochloric acid. What is the concentration of the acid? Now I'm going to go through this one with you, but I want you to do the next practice problem on your own. So please write down what I write down on this one. I always like to start by underlining what they gave us. Okay, so underline this right here. 83 milliliters of 0.45 molar solution of sodium hydroxide. What else did they give us? This right here, 235 milliliters of HCl. Now I'd like to circle what they're asking us to find. What is this really asking us? Well, the last sentence says, what is the concentration of HCl solution? So we want to know the concentration of HCl. Next thing I do is identify which one is your acid and which one is your base. This first substance, NaOH, is that an acid or a base, guys? Yeah, that's a base. How do we know? Hydroxide's in it. So this is our base, so please write that next to NaOH. Obviously, the other substance is an acid, but why is HCl the acid? One giveaway is that it starts with a hydrogen. So this is our acid. It donates the hydrogen to the base. Now, next step, write down the neutralization formula. Molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Now we simply just have to plug in the numbers to our variables and solve for the missing one. The concentration of acid, the molarity of the acid, it didn't give it to us. So I'm just going to keep it as MA. Molarity of the acid. We're going to times that by VA. What was the volume of the acid, guys? 235 milliliters. Now, can I keep it in milliliters? Sure. If I put milliliters here, it will cancel out with the other side. So watch what happens. Molarity of the base. Well, molarity is given with a capital M sign. 0.45, 0.45 goes in for molarity of the base. And the volume of the base was right here, 83 milliliters. Okay, what should I do to get molarity of the acid by itself? Well, let's divide both sides by 235 milliliters. Divide this by 235 milliliters. What do you notice happens? Well, on the left side, cancels out. 235 milliliters divided by 235 milliliters is 1. That's why we did it, to try to get it to cancel out. The only thing left here is molarity of the acid. But I also wanted you to take note of what's happening with milliliters. What's milliliters divided by milliliters, guys? Cancels out. So as long as your volume units are the same on both sides, you'll be fine. So now we just take a calculator. Now be careful. You need to do 0.45 times 83 first. That's the first thing. The orders of operation matters here. So 0.45 times 83, then hit equals. Then divide it by 235. So my molarity of the acid is 0.16 if you round it to 2 decimal places. Now, how would a chemist report this? Well, they would say it's 0.16 molar of what substance? What was the acid? HCl. Okay, so there's your answer. Can you determine the concentration of an unknown solution using a titration? Yes, you can. And you use the neutralization formula right here to help us out. Okay, the last practice problem of the whole chapter right here. Practice problem number 22. I would like you guys to try this one on your own. So if you're watching the video right now, please go through the same steps that I just used. I want you to try practice problem 22. So please hit pause on your video. Once you have your answer, hit play and see if you got it right. All right, so hopefully you have an answer at this point. What I would have done was underline what they gave us and circle what it is they wanted us to find. Then I would have identified which one was your acid and which one was your base. Because it has hydroxide, this is going to be the base. Because this one starts with an H and the other one's a base, this one's got to be our acid. It's going to donate its hydrogen to the hydroxide to make water. Okay, now what I would have done was write the neutralization formula. The molarity of the acid is what it was asking us to find. So I don't know its concentration. I'm just going to keep it as Ma. The volume of the acid they gave us, 375 milliliters. Okay, let's set that equal to the molarity of the base. Wherever you see capital M, that's the molarity. So 0.24 goes in for the molarity of the base. And the volume of the base was 25.5. 25.5, and that's in milliliters. So, thing to watch out for. Are my units the same on both sides? And they are in this case, so that's a good thing. So now let's get Ma by itself. I would divide both sides by 375 milliliters. Cancels out on this side. My milliliters will cancel out here. And so Ma, the molarity of the acid, is equal to 0.24 times 25.5. Let's do that calculation first. 0.24 times 25.5. Then hit equals. Then divide it by 375. Okay, the molarity of this acid is equal to 0.016. Now, how would a chemist report that? They would write this. 0.016 capital M, and then identify the acid, which was HCl. Okay. Very good, guys. That's the chapter, and hopefully it all makes sense to you. Before I quit the video, I would like you to get more practice with using neutralization, this neutralization formula right here, and also with titration type questions. So I've got a worksheet in your student workbook. It's titled Neutralization and Titration Worksheet. So let's go there now and complete that. Again, it's called Neutralization and Titration Worksheet. And hopefully this video helped you.